welcome to Chemical Wisdom. So today we are going to be looking at chemical bonding. We're actually starting a series on chemical bonding. So please make sure to follow up on the subsequent videos because we'll be dealing basically on the different types of chemical bonding based on the two classifications from the intermolecular forces to the intramolecular forces. So before then, I need us to look at the stability of atoms because that's where all these things originate from. If you consider these three atoms now, the atomic structure of neon, the atomic structure of sodium, and the atomic structure of chlorine, you find out that there are differences. Look at this neon, for example. It has 1, 2, 3, 4, 5, 6, 7, 8 in its valence shell. What does that mean? The atom of neon is stable or unreactive. Whenever the valence shell of an atom is being filled up, that means that atom is stable. It's not going to react with other atoms. But if we look at this atom of sodium now, this sodium atom, it has only one valence electron. What does that mean? Sodium is highly reactive. It's going to react in an attempt to obtain a completely filled valence shell. So we are going to be looking at that, especially in the electrovalence bonding. So in the next video, we are going to be dealing on electrovalence bonding. So make sure to follow up. Please make sure to follow up. So if you look at this chlorine atom now, it has 1, 2, 3, 4, 5, 6, 7. It has 7 valence electron. What does that mean? The chlorine atom here is not stable. It's not stable in that the valence shell is not completely filled up. So that's why atoms get involved in chemical bonding. It's an attempt for them to fill up the valence shell. So that's what gives rise to the different types of bonding. We're going to be looking at that in the subsequent videos. Because all of them want to behave like the members of the noble gases. Example, neon. Neon is already stable. It's not going to react. So these guys now, they want to receive stability too. That's why they are reactive. They will do anything to obtain that same stability. So you need to understand that atoms that have 1 or 2 or 3 valence electron are called metals. Atoms that have 3 or 2 or 1 electron in their valence shell, they are known as metals. So the way they form bond with other atoms is by transferring those valence electron. They don't share, they don't gain. What they are considered as highly electropositive elements. What does that mean? They have a high tendency of giving off electrons than receiving electrons. That's why they are considered to be electropositive. But atoms that have between 5 to 7 valence electrons, like the chlorine atom now, for instance, it has 7 valence electrons. If you look at the atomic structure of oxygen, it has 6. If you look at that of nitrogen, it has 5. What do I mean? They are known as non-metals and are considered to be electronegative in that they are willing to receive electrons than give out electrons. Like this chlorine atom now, if you look at it, is more willing to receive an additional electron here, which will make it 1, 2, 3, 4, 5, 6, 7, 8. Yes, the same thing with those that have 6. And the same thing with those that have 5. But if we look at this sodium now, there's a higher tendency to lose this single electron than to start gaining 1, 2, 3, 4, 5, 6, 7. 7 additional electrons to obtain that stability. That's why they are considered to be electropositive, and the non-metals are considered to be electronegative. So as we're going to be moving down on the types of bonding, we'll be discussing more about that. So basically in this series, we are going to be dealing with the types of bond from the types of intramolecular forces. We are going to be dealing on the electrovalence bond and the covalent bonding, the coordinate covalent bonding, the metallic bonding. And from the second class, the intermolecular forces, we'll be dealing on the dipole-dipole bond. Example, the hydrogen bond. I don't know if you have heard of it before. We are going to be dealing on the ion-dipole bond, the ion-induced dipole bond, and the dipole-induced dipole bond. So please make sure to hit the subscribe button. And if you like this video, please make sure to click on the like button. And most importantly, click on the bell icon so as to get notifications. We are running a series on chemical bonding. You don't want to miss out. Next video that is coming up, we're going to be treating the first type of the intramolecular forces, the electrovalence bonding. So make sure to follow through on the video. And if you like it, click on the like button.